Uh, in today's little lab, you're going to find your hang time, but we're going to look at Michael Jordan's as an example. Number 23 from Chicago. Common misconception is that Michael Jordan, actually, you know what? You tell me. What do you think? How long is he in the air for? If you ask the average person in the street, they would say an NBA superstar can hang in the air for like 5 seconds, 3 seconds. Okay. You know what? We'll find out. Okay. Let's see. One thing that's kind of scary, though, is once you find your hang time, you'll see either how athletic or not athletic you are. And I found out for me that if I jump in the air and I try to block like Michael Jordan or D Rose here, okay, by the time they go up and I go up and I come down and I go up and I come down, they're still going up. So I would have to jump twice to try to stop them just going up, okay? So anyway, during the 1984 Olympic Dream Team, Michael Jordan set a personal record for himself. He had a 42-inch vertical leap at a height of 6'6", weight of 216 pounds. Just so you can appreciate that, 42 inches. Okay, this is a meter stick here, right? This is 39 for a meter stick here. So it's about 3 more inches on top of that, okay? So that would be his feet leaving the lab table right here, and the bottom of his feet go like up to here, okay? If he's jumping from the lab table. So let's say he jumps from the ground, 39 inches is there. Let's add on like 3 more inches or so. That's like about up to my belly, okay? So if he jumps and his feet, the bottom of his feet go up to my belly, then where's the rest of him? He's like 6 foot, what? 6, and he sticks his hands up. All he would have to do is jump, tuck his feet. He'd just fly right over me, right? And there's a classic slam dunk from the free throw line, right? The Air Jordan pose there. So anyway, today we're going to figure out Michael Jordan's hang time based on his vertical leap. And then you're just going to measure your vertical leap in a second to find your hang time. Step 1, let's make a simple little what? A little sketch, okay? So in the old days, when the Chicago Bulls were unstoppable, those were good days for Chicago sports here. Here we go. We had one of the greatest NBA players of all time, Michael Jordan. There we go. 23. Let's put some clothes on him. There we go. I don't know. Draw. That's okay. We're just going to sketch it out. Oh, he should have some pants. There we go. Something like that. There we go. Got to have the Nikes on there, right? And then what's his signature thing? Anyone know when he jumps in the air? There you go. Got to have the tongue waving out there, okay? That's his tongue. That's okay. Whatever. You get the idea, yeah? And here's a simple idea, right? What goes up must what? Come down, even though Michael Jordan said, I feel like I'll never have to come down, okay? One little trick is when he actually jumps in the air, he actually stretches his body out, which lowers your center of gravity. So literally, there's the illusion of hanging in the air longer because you flatten out that parabola. The other thing, too, is if you tuck your feet, then it takes you a little bit longer to hit the ground, too. So technically, you can extend your hang time a little bit longer. Okay? So the hang time for an athlete would define as from when the athlete's feet, what, leaves the ground to what? When it comes back down, right? Okay? And obviously, for a basketball player, it's to your advantage to have a very long hang time because that means you get higher in the air, you have longer time in the air to take your shot, or pass the ball on, or slam dunk it, or pass it between hands, and then dunk it, whatever, okay? So our goal is to figure out his hang time based on one little number. And what's that? He has a what? 42-inch vertical there, right? So that's our delta what? In step 2. Our delta x, right? 42 inches. So one thing we should probably do first is convert inches to what? Feet. Let's go and keep our units consistent. We'll just take 42 inches, and then if we divide 12 inches in a foot, it's just 3.5 feet, okay? So 42 inches is simply 3.5 feet. Now here's a little trick, okay? We can either solve for the whole thing, which is kind of a pain, or we can apply that fancy thing. What's that called? It starts with an S. Symmetry. We can solve for going up or coming down. Which one do you guys want to do? Doesn't really matter, right? Okay? Why don't we list all our knowns and unknowns, then we'll figure it out. Okay? So when it comes to free fall, what are our knowns and unknowns? Like speed, distance, and time? No, bad. No SDT, right? Like things like what? Delta X, what else? V what? VI what? VF, what else? A and what? Time, okay? What's our goal in this problem? We really want to find what? Time, right? Put a star around it, okay? Assume for now Michael Jordan is on which planet? Earth. Welcome. We come in peace, right? And unless this is Space Jam, you guys ever see that old one with Bugs Bunny? It's kind of funny, right? Yeah. We'll assume he's on Earth. It's going to be negative what? 30, what in feet, guys? 32, right? Feet per second squared. 9.8 meters per second squared. We're going to use 32 if we're talking feet. Okay? So basketball, even though I think it was actually a Canadian who invented it, it's still pretty North American, right? So we're going to stick with feet here. So now we're just stuck with VI and VF, right? So why don't we use symmetry? Let's make our life easier. We don't know how fast he jumped off the ground from, right? So there's a little trick. Why don't we just solve for coming from where? Right here at the peak, okay? So here's a little trick. Write it down at the top. Trick. We're going to use symmetry, okay? Little trick. The trick is we're only going to solve for going down. Solve down, okay? Solve for going down. We're only going to do half of his jump. So we're not going to find the total time. We're just going to find the time for him to fall down from 42 inches. That's ridiculous. Okay? How long does it take an athlete to fall from 42 inches? So then, what can we call the initial velocity? For a brief moment in time, at the very peak, the initial velocity is a big fat what? 0 feet per second. We don't know VF. We probably don't need to find it. Okay? Because if you look, as long as you have 3 out of the 5 variables, you can solve it. In other words, we don't know for a brief instant. Okay? I just grabbed my tape roll here. He jumps up. He comes back down. For a brief instant in time, he's just hanging there at the peak. Okay? So now let's look at our toolbox of equations. I want to know time. I know delta x is negative 3.5 feet. Oh, actually, I didn't say that, right? Since we're solving for down, what should we make delta x? That's important. Delta x should be what? To stay consistent. It's got to be what? Negative 3.5, okay? Otherwise, we're not being consistent there, and the numbers don't come out. Actually, you can't take the square root of a negative number. And then I noticed some people on the problem set, like if they use nifty number 4, VF squared equals VI squared plus 2a delta x. If you have your delta x negative and your acceleration is negative, then you're consistent. It works out. Otherwise, you throw your numbers off. That's okay. VI is 0. Don't know VF. A is negative 32. Only one equation is going to work. Which one? The one that doesn't have VF. We use it all the time. Nifty number what? 3. Delta x equals VIT plus 1/2 AT squared. Okay? It's what you don't know that helps you get the answer. If you look in our toolbox, you can see that there's only one equation that doesn't have VF. It's this one right here, right? Nifty number 3. So you see how what you don't know leads you to the right equation, the right tool to solve it. Okay? So anyway, let's finish the sucker off. Let's go ahead and plug and chug. What do we put in for delta x? Let's put in negative what? 3.5, right? What's the initial velocity at the peak? A big fat 0, because you're hanging there at the top. 1/2 negative 32, solve for time squared, okay? Little speed algebra. Half of 32 is negative 16. Divide that out. Take the square root of both sides. The two negatives become positive because we were consistent in calling down, down. You see that? So anytime you try to take the square root of a negative number, that means you weren't consistent. Go back and fix step 2 to keep you consistent. You see that? So now we can finally solve. Let's go ahead and plug in. In our calculators, we want to simply take then the square root of our delta x, which is fallen from 42 inches, 3.5 feet. So that's 3.5 over 16. And we get a time of 0.4677. Let's just round that off to 0.47 seconds, okay? So the time down is 0.47 seconds. How do I get the total hang time then? Okay, yeah, if I want the time total, if I just multiply by 2, I'll get my total hang time. Okay? So for Michael Jordan, we'll multiply that by 2. It's about 0.935, 0.94 seconds. Good enough. Okay? So notice, even a superstar like Michael Jordan, he's not even in the air for 1 second. That's crazy. Okay? So there's two ways to look at this. One way is like, that sucks. Michael Jordan's not even there for a second, right? But another way to look at that is to appreciate the athleticism, that he can take off from the free throw line, dunk it, right? Jump in the air, throw it to his left hand, pass it off to somebody, right? Jump in the air, go up with the left hand, boom, dunk with the right hand, etc. Okay? So what's amazing is most NBA players at the top of their game, their hang time's not even a second because you live in an ocean of gravity. You just kind of take it for granted. It's the ultimate hot rod. 0 to 60 in 2.7 seconds, negative 9.8 meters per second every second. Okay? So now what we're going to do is have you find your hang time based on your vertical leap. Okay? So here's how you're going to do it.